Okay, so we are going to look at quadratics starting from now, and we're going to be able to know how to do all of this after we've done the whole study, but not after just today. We're going to be able to plot quadratics, we're going to be able to solve quadratics, and we're going to be able to identify key points of quadratics, which is basically all we need to do with them at the moment. And there's not particularly much more you can actually do with them if you move on to A level, etc. But today we are just going to look at to know how to plot quadratic graphs, not the read-off solutions. That comes at a later lesson. That's just on the bottom of this PowerPoint, which you'll see another time. So, what is a quadratic? First thing, it's important to actually know what I mean with this fancy quadratic word. You'll have heard of it before, I'm sure. It's a word that people like to throw out as a scary maths word, but it's not actually a very scary maths word. A quadratic function is just something where the highest power of x is x squared. And by I mean highest power, I mean there's no x cubed, there's no x to the 4, there's no x to the 5. So this first one is just x squared. This is x squared plus 3. It still has the highest power of x squared. Whatever comes after that, fine. It'll just change the graph looking a little bit, but it'll still look the main idea of the graph will still look the same. X squared plus 3x. We've got some more x's in there, but they're all lower powers. The highest power in the graph always kind of takes control and makes it look how it looks. So this x squared is still going to be the most prominent one here. So this is still a quadratic. And although this is written back to front, it's still a quadratic. The highest power is x squared. And we can have a negative power as well. We can have a negative x squared as well. I'll show you what that looks like in a second. So we're going to learn how to draw them, and there's some key points here. So when you're drawing a quadratic function, you want to draw a table of values. I'll show you that in a second. Calculate the y for each of the values of x, which is what you did when we were looking at straight lines. Draw a suitable grid or use a suitable grid given to you, and then you plot the coordinates and you draw it importantly with a very smooth curve. It's not a dot-to-dot game, no straight lines. This is a smooth curve, and it doesn't have to be beautiful, just to the best you can. So I'm actually going to dip out of this PowerPoint for a second, and when I do that I want you to ignore the time and the date. I've had a lot of internet problems this weekend, and this is the first time I've been able to actually get on my computer properly to do this. So we're just going to have a quick look at what quadratics look like. So y equals x squared. So here we are. This is just your basic y equals x squared graph, and it is a curved, bit of a smiley face. Imagine a little two eyes there and a nose. Most people like to describe it as a U shape or a smiley shape. And if I just plot some other ones, so y equals x squared plus 2, okay, so it seems like it's the same type of graph. It's just been moved up a little bit. It's been moved up by 2 actually, as soon as I've put the plus 2 in there. Okay, how about if I chuck in a y equals x squared plus 3x minus 1. Typed that one in wrong, didn't I? So y equals x squared, that's better, minus 3x minus 1. Hopefully you can see in the bottom left what I'm typing in, and then it comes up here. I'll delete that one. So again, it's been moved a little bit. I can't quite describe exactly how it's moved, because I don't know exactly how it's been moved, but it still looks like the U shape. Nice and curved. It's just been moved somehow by the minus 3x's and the minus 1. Well, I can see this minus 1 at the end is actually where it crosses our y-axis, and that's always the case. If there's just a plus or a minus number at the end, that's always going to show where it crosses the axis, but we'll look at that in more detail another time. And then if I look at my final one, so y equals minus x squared, what do you think that's going to look like? So I'll pop up positive and negative. This is, the one on the top is positive x squared. The one on below is minus x squared. So if we have a minus x squared graph, it looks like a frowny face. And I like to remember it when we've got positive, we're smiling, and when we're negative, we're frowning, because that's pretty accurate to what happens. So if I just look at another one, y equals minus x squared plus 4x, so we've got a plus in there somewhere, but because it's a minus x squared, that's taking control. It doesn't matter what else we have there. So that is the minus x squared plus 4x plus 2. And we can see that that again is a frowny quadratic. So when you go ahead and plot some of these, you might see that some of them go this way. Just double check that it is a negative one, and that'll show you that you're on the right lines. So this is kind of a little walkthrough of how we would substitute some values in. So this shouldn't be brand new to you. I'm pretty sure we've done some stuff like very similar to this, if not exactly like this. So you're just going to draw yourself a little table of values. They might give it to you. Just pick some nice values. Between minus 3 and 3, we can see you've got up in jumps of 2 here. So minus 3, 1, 0, 1, 3. They've done some weird jumps there. But you can just do minus 2, 1, 0, 1 and 2. Something like that. Always get about at least 3, 4, 5 in there. Around the 0 mark is always going to be handy. So that box there, that's basically going to be, well, y equals x squared plus 1 when x is minus 3. So we want to do minus 3 squared. The minus 3 is where this x has been. And when you remember, if you do a minus number times by a minus number, we get a positive. If you're typing this in your calculator, have the brackets. Don't know how many times I've said this. Have the brackets like I've done on the PowerPoint here. Have the brackets around the minus 3, then the squared on the outside. Otherwise, your calculator will give you an incorrect answer. So minus 3 squared is 9, plus 1 is 10. So 10 is going to go in our box there. And we just want to rinse and repeat really, but change the value of x each time. So we're going to do minus 1 squared. That should be 1. So 1 plus 1 is 2. And we're going to pop a 2 in there. They're not really going to follow a pattern like we do with our straight lines. They're not going to go up by the same amount every time or down by the same amount every time. Because it doesn't look like that when we plot it. They go up and down a bit. So 0 squared, that will just be 1. And then as we get 2 more, we would get to that one. Maybe you can have a go at putting these 2 in and see if you get what I've put on the PowerPoint here. You might notice that we've got some similar values here. I'll not going to dive into that. That's something I'm talking about in a few lessons' time. And then when we go and plot this, so this is our table from the previous slide, we just want to plot the coordinates. So this is the coordinate minus 3, 10. So I would go minus 3 across, 10 up. And you can see we've gone through that intersection there. We'd have put a cross. I'd have put a cross there. Minus 1, 2. I'd have put a cross here. So actually I think I might draw them crosses on. Pointer options. Pen. So this would be minus 3, 10, this point here. And you can go minus 3 to the left. So you can see I'd have a point there. This is minus 1, 2. That would be my coordinate here. This is 0, 1. 0, 1 is there. This would be the coordinate 1, 2, which is there. And the coordinate 3, 10, which is here. So what we've done there is we've done a nice line through. It's best to try and do this in like one pen stroke. You don't want it to look like you've done an actual art sketch. I know it says sketch the graph, but it doesn't mean like you're drawing something in art. It just wants one swoop line like this. And I don't know why I'm still getting that line on the left. It doesn't matter if it's bang accurate, just as long as it looks sensible. Okay, another example here. So again, we want to substitute our values in. This is minus 3 squared, which would be 9, then take away 2, that gives me 7. And as I run through the rest of these, just saving my voice and repeating the same thing every time, I'll let you read off. But this is just the steps of substitution I've done. And then these are my values. Again, we're noticing a bit of symmetry in there, with the 7 on both sides and the minus 1 and the minus 2. It's not always the case. There is always symmetry in a quadratic, but it's not always around 0. but we'll get to that with some more explorations of it. And then when we plot, we would plot our points minus 3, 7, which is here. We'd plot our points minus 1, which is there, 0, minus 2, 1, minus 1, and 3, 7. So we can see that my points are all on the graph, and what we've done there is we've just drawn a nice curved line through it. Some people like to turn the page sideways so that you can draw it a bit like a C rather than a U, because it's a bit easier with your hand, and if you're left-handed you might want to flip it the other way so you're drawing a bit of a backwards C. I'll let you experiment and see what you like the best about that. So these are some questions that you'll be looking at, but I just want to show you one more example. Don't take notice to what's on the screen here. So this example, so you might get a quadratic with a few more terms. You might not think that's a problem, you might be able to substitute stuff into that, no problem at all, but this is just an option. You can set up a table like this, so you can see I've got the x squared here, the plus x there, I've not written the plus because I don't need to, but I could have, and the minus 2 there, I've made sure to write the minus. What you can do is just go down and do minus 3 as x squared, so minus 3 squared would be 9. Minus 3, when x is minus 3, well x would just be minus 3, and minus 2, there's no substitution here, there's no x's, so that is just minus 2. You can see that that's what I've got here. And then the final job, I've just completed the rest of the table there. The final job is, well, y is what we're actually after, isn't it? And that is the combination of all of these, so x squared plus x minus 2. So that would be 9 minus 3 minus 2. So that would be 4, and that would go there. And we would do the same for each. This might be a method you like to break it up in case you're making a few errors in there. If you're confident with just doing it all at once, feel free to do it all at once, but this is just an option there for you. So we notice actually, after we've done all of that, we don't need all of that. This is actually our coordinates, minus 3, 4. We've got a coordinate here of minus 1, minus 2, etc, etc, 0, minus 2, 1, 0, 3, 10. Again, this time we notice we don't have some symmetry. We don't have the same numbers on either end, and that is because we've got some x term in the middle. If it's just an x squared, or an x squared plus or minus just a number, we've got symmetry around 0, but we don't when we have some x terms in the middle. And when we look on to factorising and solving, we'll see why. We'll see the graphs that link up with these, and we'll kind of see why. And that is, once I plot this, it's all I really had to say this video. That's how we would draw that graph. The coordinates you might be able to check link up. But yeah, there'll be some tasks for you, and I'll link this PowerPoint as well if you want to work through it at your own pace or just to get some examples down. We're not going to focus on what I'm talking about there, that'll be another time. But thank you for listening.